Hello everyone, and I would like to again talk about series circuit, but this time I'm not sure if I should. Well, I think I should. The videos are DC circuit, like series circuit, and DC is basically when I can't really remember. I'm going to be honest. It's either when current is able to. No, I think yes. DC is when current is able to go only one way, and the AC is when it's able to go like forward and backwards. So yeah. So basically, the types are that the circuit can have its resistors in series, and series basically means when, let's say, right, like this is the wire or whatever, and the like resistors are on one kind of loop. It's one loop, and that means that the current is the same. However, with parallel it's different. So you see how it's not like one loop, like even if it can be like this, it can also be like this. So this is also parallel, and as you can see the current, like let's say this current is going zip zip zip, it has to go here, so there's an X amount of leaving from here, so now there's less current, so it's not the same basically. And here they apply both rules. For example, so let's say there is a diode, oh a diode, that's a crazy one, a battery, and basically here's a resistor, and then resistor, and then whoop, oh no, resistor, and then so these two that are on power, like in series, I mean, because they're on the same line, so the loop is like it's not broken. Also, if there was something here, I'm pretty sure, yeah, you would still be able to call them parallel because the current over here is the same. But like if there was something here, you can't say that's parallel because the current here is different from here, because like over here it takes it away, and then when it goes here it takes it away. Like this is not series. I mean, not series. It is parallel. The way you calculate the total resistance in series, again, we're talking about series, guys. I'll just keep going blind. So let's say I have one resistor, right? And what's it called? The resistance is 5 ohms. So the total current is going to be 5 ohms. Basically, you add all the resistors, you just add them for series. So if there was, let's say, imagine, wait, how can I do this? Like this, yep. Imagine there was another resistor, and imagine this is not here for now. And so there's only two, just imagine this one's not here, and the second one is 10 ohms. Then the total resistance would be 15 because you add another 10. And then now this time let's include the third one, and let's say the resistance was 2. The total resistance would be 17 ohms. So you just basically add them. RT equals R1 plus R2 plus R3. It can go like until whatever you want, like 6, 7. So let's say we have a circuit, right? And the voltage of the battery is 9. So the way like the voltage works in series is the same as like the current. It's the same throughout. However, you like are looking at these two and you're like, wait, why these 9.5 but this one's 9? So look, what is voltage? Basically, voltage is the difference, kind of the difference between like 2 points. So let's say you have a battery, right? And you measure like the voltage of it. Let's say it gives you 1.5 volts, or it's a bad battery. However, if you try to measure it from 1 point, it will give you 0. So it's basically like difference. So let's say the voltage is like applied force to the current, right? Over here, because it's measuring the, what's it called, like 2 points of difference, is different through the 9 because the 9 basically goes throughout. It's the difference between like these two, like this whole thing, which is basically the whole circuit, because after that there's no resistors. Well, I don't know how to explain it, but basically the difference, because like so there's 2 points, you just half it. Basically that's the logic, kind of. So however, I kind of explained it like kind of wrong. So this time let's have 2 resistors, right? So, and like let's say like you measure the voltage right over these two, it will be 9, right? However, last time, like, you know, the current splitted. Like, how can I explain? So the way you measure voltage for each, like, so basically the total current, like the current of the circuit, is the voltage divided by the how much was it called? How much resistance there is. So the answer is 0.6, and so the current is 0.6. However, the voltage is different throughout. I'm sorry, I made this kind of wrong, but like basically, like it's very hard to understand, kind of. But basically, what you do is 0.6 times 10 equals 6. So over here, the voltage will be 6. Over here is going to be 3 because 0.6 times 5 equals 3. 3. So, and then they add to 9, so it does make sense. And sorry for the confusion, but that's kind of it. This time, basically, yeah, just follow the voltage, Ohm's law. I times, what was it, resistance. Basically, just follow this and use your brain. So let's say how we measure power. So the current is the current is 9 over 10, so it's going to be 0.9 amps. So, and the way we measure power, there are 3 ways. So the first method is V squared divided by the resistance. So that will be 9 squared divided by 10, which will equal to this. And the second method is V times current. Why am I doing 8? Why did he say 8? That's actually not the best. Current, so yeah. And then so the voltage 9, the current 0.9, and that equals to the same answer because it's the same power. The third method that the video didn't even include, by the way, so this is my own knowledge. It is the I squared, current squared, times the resistance. So 0.9 squared times 10, which equals to the same, and the unit is watts. So W to all of you. And don't be scared if there's another. Basically, let's say we add another resistor, right? And it's 5. This time, ignore these. Now the current will be different. The current is going to be 9 over 15. So now let's just use one. Let's use this one because why not? 0.6 times what's our resistance? 15 equals. I hate when it does this. Apple, I want a refund. Here, so 5.4 watts. And just so we make sure, just for your own, you know, like so you are not scared to do this yourself, 9, the voltage, let's use this one, squared divided by 15. That is not, oh my god. So the same, let's go. So basically the same. And now let's talk about parallel circuits. Okay, last time we talked about series, right? So like the current goes here, right? And an important fact is that I kind of missed out for this point. If like one bulb breaks, like the whole thing stops working, because that's just how it works. It's trying to get here, but like because it's broken, it's not even gonna go. And the solution to that is to wire the circuit in parallel, because the current goes right. It has two ways. If this one's broken, it's just not gonna go this to this wire. Over here it's gonna be like no, road closed, and over here it's gonna be like beep 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 beep, and just continue. And I'm not really sure about this. However, like maybe you can even say that after that it's going to be like series. However, probably not. You can do it a very simple way. Straight away calculating what are the small ones. So, as we know, current equals V divided by R, or divided by R. So we're able just to do, for example, for R1, we're able just to do 12 divided by 15 equals, okay, 12 divided by 15, please, equals 0.8. Then 12 divided by 24 equals 0.5. So over here the current would be 0.8, and over here the current would be 0.5. And this is wrong because I'm an idiot, guys. Yes, this is the way to calculate the current in parallel. However, it's better to use this method because then you can just add these two, and so the current will be 1.3. So let's do it with a kind of harder one. So let's just quickly, so this will be, let's solve the current for each one. So over here it's 6 divided by 10, which is 0.6, so 6, amps. Over here 3 amps, and over here it's going to be 6 divided by 5, wait, did I do this divided by, 1.2 amps. And just to make sure that I did it right, I don't know why I was glitching. So, that's 0.6. So now, from what we know from this, we can add all of these, and we will get 3 plus 1.2 plus 0.6, 4.8. So the total current is 4.8. So imagine this, right? The current is going, right? Okay, done. Over here, it took away 0.6. So now it is left with 4.2. It's going, done, minus 3. So now it's left with 1.2. It's going from here, and then it reconnects here. So these two. So before it reconnected, the current here was, it would be 1.2. However, now from this moment, after they connected over here, it would be 4.2 because 2 plus this, and then after it connects with this, and then 4.8. So so now the total current basically means RT over 1 equals R1 plus R2 plus R3, and so on, which this is basically this, like we need only the RT, so we can say that RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So this is 1 over all of them. So let's say we have a circuit. Oh wait, why am I always putting a V? Let's say the circuit is like only 2 branches and 10 and 5 ohms. So we can just do 1 over 1 over 10 plus 1 over 5, which then equals 2. And so the R total, so like what R total is, it's basically these two connected. Like instead of having all of this, it's the plus 1 and having 1 of it, and this 1. So if we do all of these calculations, we realize that 3.3 basically recurring. This 1, if we like did the same circuit, but instead of having 2 of these we have 1, it would be equal to 3.3 ohms, and these two would be the same. Like they would have the same power, and it like not exactly that, but kind of function, if that makes sense. And the power stuff are the same. So yeah.